Click live.
Hi, everybody. Welcome to our stream. Sorry that we're having some technical difficulties. Apparently, YouTube deleted our other stream that we planned on hosting this on. So we're trying to host this one right here. So if you're not here, get here now. We're going to hang out for a few minutes for you to all show up.
Make sure we're all set up and ready to go. I hope everybody's ready to celebrate. It's a birthday.
I love a good birthday party. So I hope you found this chat, or I should say chat, I hope you found this stream. We want to make sure that everybody made it back here when YouTube deleted our other video or made it go live. I see the number is slowly increasing.
Who's scrambling can find the right place to run to.
Yeah, it's very strange what happened there, but we're glad that you found the right stream. So if you or your friends got lost because YouTube voided our other one, then go tell them to show up to this stream. We've got a lot of fun stuff in store today. And if you've been seeing our other streams, it's still worth you tuning into this one because this stream is still going to be unique. We're going to show you some new things we haven't shown on Monday or Wednesday. We're just going to give it a few minutes, make sure that because of that technical difficulty, everybody signs in. Everybody who wants to see it can. All right. So it looks like we have everybody who was waiting from the other stream now over at this stream. So let's get started. And I'd like to start by welcoming all of you to Dome to Home, our web series. This web series is going to be talking about the 30th birthday of the Hubble Space Telescope. And this one is welcome to anyone and everyone. So tell your friends, tell your neighbors, get your cat and dog watching, your goldfish. We want all of them here, and especially chatting in our chat box down below. We're going to answer as many of your questions as we can today, as well as tell you a lot about the Hubble Space Telescope. So I want to start by introducing myself. I am Nick Conant. I'm the theater manager at Fiske Planetarium. But since there's no theater to actually manage today, because we're closed, we'll be using our virtual theater that you'll see over here. And I think I'm pointing in the right direction. Yeah, that's the right direction. And we're joined by Amanda.
Amanda, hi. I'm going to be your navigator. I'm also a student at CU, doing remote classes, doing remote working. It's a little bit weird, but since I can't do laser shows for you guys at the Dome, I figured we'd do something else really cool online. You guys can still get your astronomy fixed, and I can still work at the best planetarium.
And Amanda's actually going to be controlling our virtual planetarium for us, showing all the images and pictures for our trip today through the universe. So first, we're actually going to be looking a little bit about the amazing stuff Hubble's been doing. Then we're going to focus a little bit on how, like, some of its history, how it's been working. We're going to take a flight through the universe to visit some of the places that it's actually been looking at for the last 30 years. And we're going to especially end by taking your questions. So let's start by also pointing out that our chat moderator, Jeremy, I want to thank him, and Brianna as well. They'll be helping us in the back end in the chat and making sure that the stream works flawlessly.
So if you guys have any questions at any point, feel free to drop them right in there because Jeremy is looking out for us.
Absolutely. Thank you, Jeremy. Thank you, Brianna. Now, over the past 30 years, Hubble has given us some of the most beautiful images of space, undoubtedly, ones that inspire future astronomers and people to be interested in space. Things like the Hubble Space Telescope, very enthralling. Things like Jupiter, I should say. and things that are much further away than our solar system. Hubble can look at star clusters and especially this beautiful galaxy here. This is the Whirlpool galaxy, about 23 million light years away. Amazing. Now, Hubble itself um, has been up in space for about 30 years, and we thought since it's its birthday, we should get to know it a little bit better. So what we're going to do is first honor a little bit of history because Hubble hasn't always been up there. And where did it even get its name from?
Yeah, that's a great question. So the telescope itself is named after an astronomer named Edwin Hubble, seen here. And he made one of the most important discoveries in history using the 100-inch Hooker telescope at Mount Wilson in California. And we can take a look at that telescope too. It's quite impressive. Now, he discovered that our Milky Way wasn't everything in the universe, that there are millions of other galaxies, and the whole universe is much, much larger than we ever imagined. So I think it's pretty appropriate that we named the first great space telescope after Edwin, especially since it's nearly the same size as the one he used on Mount Wilson.
Yeah, the
So
one
let's
in
go visit
space.
Hubble.
Yeah, let's go visit Hubble up close. So the telescope in space itself is about 8 feet across, 8 feet in diameter. Is the size of its mirror, and the one at Mount Hooker was 100 inches, which is I think it's only 4 inches wider. But you can imagine that the one that we showed you in the picture is very similar in size to Hubble. But first, here we've blasted off of the Earth, and we're looking back down on it, and we can see the very thin blue line around the Earth, its atmosphere. Hubble lies just above that thin blue line, 400 miles above Earth's surface. So for many of you, Hubble would be closer than, say, Paris, just a few hundred miles above the ground when it flies overhead. Now we're going to try to zoom up close to it. And so we're going to have to pivot around and find out exactly where is Hubble in outer space. And this thing is only about the size of a school bus. So for us to actually get there, we're going to have to zoom in really closely, zoom and enhance. Woo. Looks like it's actually on the night side of the planet. Hubble orbits so quickly that it goes around at 16,000 miles an hour. It takes only about 90 minutes, an hour and a half, for Hubble to circle around the Earth. And so what we might do is we might actually bring Hubble around to the daytime side. We might need to advance time by something like 45 minutes to get it to daytime. But um, Hubble is also such a small object in comparison to our whole planet that it can be difficult to find sometimes. Now, the Space Telescope, when it was launched back in 30 years ago in 1990, was actually planned back in the 1960s. That NASA and many space enthusiasts knew that a telescope in space would be the next great advancement for humankind, and so they developed a number of different space telescopes that did rudimentary things. But eventually, Hubble was the sort of the cherry on top. Hubble was the first really large space telescope to be um, implemented and put into space. It took it a number of years. It went very over budget, but it accomplished things that no telescope would have been able to do before. Ta-da! Hubble. Now, Hubble has these large solar panels you can see on the side, this very large tube which houses its mirror down in there, and a whole array, a huge suite of sweet equipment. And it's also worth noting that when Hubble got into outer space, it took it about a few weeks to actually get functional and to start taking its first pictures. And when they did start to take the first pictures, well, let's show you what the first picture of Hubble actually looked like. Oh yeah, look at those stars. So the one on the left is showing us an equally sized telescope, a 100-inch telescope from the ground. And those stars look a little bit fuzzy. And then the one on the right shows us a picture that Hubble took. And you can see that the one on the right, the topmost star, you can see two stars, is sort of connected like a figure eight, as where the one on the ground just couldn't resolve them very well. So trying to look through all the atmosphere around the Earth makes it a lot harder to spot, to resolve stars and things in outer space, especially when Hubble was first uh, concocted. Now ground-based telescopes can do a lot better than this, but Hubble was certainly a huge step up for the era. One thing that isn't really showing out in this picture is that Hubble was actually launched with a flaw. And this was a huge flaw that was actually only about 1/50th the width of a human hair. It was on its mirror. So let's take a look at a picture of Hubble's mirror. It's, like I said, 8 feet wide, about 2.4 meters. And this mirror needed to be ground extremely precisely. And it was to be the first project that would be ground with computer-based understanding of how to grind mirrors. But something went a little bit wrong, and it was slightly off. The curvature of the mirror was off, but like I said, the width of only a few microns, a 50th the width of a human hair. And so this means that Hubble was taking somewhat flawed pictures. But first, I think it might be good to look at how the different types of telescopes and how they work. So, like I said, the mirror itself was a little bit flawed. And that means that if I were to instead have tried to launch a piece of glass into space, say, like most telescopes on the ground would use something like a piece of glass, like this magnifying glass. And so Hubble works like a giant eye, like this one I have right on my face. It's like one really big eye that's 8 feet across. So if my eyes were as big as Hubble's, I would probably be able to see some miraculous things in outer space. And if I pop out the lens for this magnifying glass, telescopes that use lenses like these that are curved on both sides are called refractors. Hubble doesn't use a giant piece of glass because to get a piece of glass this large, as we had been practicing for many, many um, years, how to make, many decades, to get a piece of glass this size up into space would be a Herculean effort. It would weigh a whole lot, and trying to keep it warm in the cold depths of space would be very difficult. So naturally, we want to use something reflective, like a curved piece of metal. In this case, I have this spoon here, which is like a curved reflective surface, like that Hubble would have. I don't actually have a curved mirror in my possession, but this spoon works similarly. But imagine trying to grind this spoon down to the width of just a few microns. Very, very difficult thing to do. Now, the uh, Hubble Space Telescope's mirror was slightly off. And we have an array of pictures here that show you, actually just, I think we're just going to bring up a picture of a blurry galaxy that it took a picture of there. They were dismayed by how this galaxy didn't look like how it really should look. And if we then consider what it really should look like, the corrected image, yeah, just like this, looks much sharper, right? Of course, we know that Hubble can take much better pictures than this, but Hubble was trying to take pictures with this incorrect mirror. And so thankfully, there were an array of surfacing missions that the Space Telescope Committee had planned using the Space Shuttle. And so the Space Shuttle itself was designed to launch Hubble and designed to service it. So it went on 5 servicing missions between 1990 and 2009, about that 20-year period, to service Hubble. And the first one came after only a few years, and they installed corrective optics inside of it. They installed mirrors that would counteract the flaw in the Hubble primary mirror. And then over time, they corrected, they started to fix solar panels that had been damaged. They started to add gyroscopic wheels that had been fixed, and a number of other improvements and upgrades over the years. So now we have the best, most spectacular images coming from Hubble are from the advanced technology inside of it. Now, Amanda, could we show just how large Hubble is in comparison to a normal telescope or something? Something that we
Or
might
maybe something like a school bus.
like a school bus. So if we magically put a school bus up in space, like a magic school bus, there we go. We could see in comparison to size.
School
So
bus felt like an appropriate choice.
yeah, and you can see how it's nearly the exact same size. So something this large in space really took a lot of engineering and took more than $1 billion to accomplish. But now its beautiful pictures grace us all the time. So what do you say that we go into outer space, further into outer space, and try to look at what Hubble has been looking at all these years? So this is our
I
trip
think that sounds
through the universe.
fantastic.
All right, everybody say bye, Hubble, and happy birthday, because we're going to go explore what it's been looking at this whole time. And I'm going to try to fix the focus on my camera. Now, as we fly away from Hubble, woo, there goes the Earth. We'll show the orbit of the moon and eventually the orbits of the other planets in our solar system. There we go. That should make it a little bit better. So Hubble is, like I said, only a few hundred miles above the surface of Earth. All the other satellites lie within sort of that range or within a few thousand miles of Earth. And our closest natural satellite, the moon, lies about 240,000 miles away from Earth. That's about 400,000 kilometers. We can point Hubble at these things, but in fact, when we want to look at objects within our solar system, that's perhaps the closest objects that we really want to point Hubble at. So you saw famously that great picture of Jupiter. There was a comet that impacted Jupiter back in the 90s called Shoemaker-Levy 9. And it was imperative that the astronomical community point their space telescope at Jupiter and see the impacts of the comet into Jupiter's atmosphere as it broke up. But other things that are more distant, like Uranus and Neptune, we haven't sent spacecraft to them since Voyager 2 was the only spacecraft to ever visit Uranus and Neptune. And so we can use Hubble to look at how they're doing without actually having to send a probe there and have it take 10 years to try to reach those distant planets. Well, if we point Hubble at things even more distant, further out in our further out than our solar system, we can get really far out and start to see some of those miraculous images that we're all familiar with. So here we are, we're flying so fast that we've exceeded the speed of light millions of times over, and we're zipping by other nearby stars. Do you recognize these stars, Amanda?
Honestly, I am extremely impressed with your starfield navigation. I see Orion flying past, but other than that, they get a little bit messed up pretty quick for me.
Well, let's
Nick is
see.
the master of finding stars in the middle of space. It's like he's been there before.
Not something we're going to do today, but we will let Hubble provide that for us. There's a great montage of Hubble pictures for open clusters. These are arrays of different stars, and I can't tell you which ones these are. They're so numerous. I think the one of these is called the Jewel Box. I think the bottom middle is part of Carina. These are different clusters of young, hot blue stars that they're born together, they die together, they usually die in explosive supernovae deaths. These are all pictures that Hubble has provided us of these brilliant star clusters, and they're just gorgeous to look at.
I agree. It's hard not to want more.
And these star clusters are normally pretty close to our solar system, close to our Earth, in comparison to other star clusters or other objects in space. So we're going to fly out and look at planetary nebulae, ones that are the stars as like our sun when they die. when our sun dies, it'll be kind of like if you were to take a marshmallow and put it in a microwave and then heat it up, it would expand, 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 and then the inside would be like burned, right? It'd be super hot on the inside. And so that's what planetary nebulae are like, is that it's just like an expanded shell of gas with the inside is kind of a burnt core left over. Yeah. So in these pictures, you can see a number of these different shapes. Some of them look like butterflies, some of them look like ants. A lot of them have insectoid names, like the red ant nebula or the butterfly nebula. Of course, you can see in the very center that burnt core I was talking about. This is the core of the star, a star like our sun, as it's starting to slowly fade away and die, and the rest of the gas is in this beautiful shell around it. The Hubble team takes these pictures of nebulae and they color code them in ways that allow astronomers to make sense of them. One of the most famous ones is this one of the Eagle Nebula. The Eagle Nebula, aka M16, the pillars of creation, is these huge structures of gas and dust that are squeezing together to form new stars and solar systems.
And it took me a long time to see the eagle shape, but someone showed it to me once, so we'll see if I can show it to you with my cursor here. So we can see we're imagining we're rotated 90 degrees from where we should be, but the eagle is flying this way with his head here. You can see his beak sticking out and his claw is right here and his wing is even spread out nice and thin like an actual eagle's wing would be. So it's actually kind of cool. I really enjoyed it when somebody explained that to me.
Ah, they're telling us that we can't quite see the cursor.
Oh, that's too bad. Hopefully you guys can imagine it with me. Look more towards the right half of the picture. The right half of the picture, the left half of the picture isn't too incorporated in the eagle, but the right half of the picture, if you tilt your head to the left, you can kind of see the eagle. That thin little patch of gas down towards the bottom right is his wing, super thin, like an eagle's wing would be. Hopefully you guys can see that.
You know, I've heard critiques of what we call these things in space, where people say you can't call that an Eagle Nebula. It looks much more like a cucumber, like three cucumbers sitting side by side. But the three cucumber nebula wouldn't be a great name, would it? Or maybe it
Triple
looks,
cucumber.
yeah, triple cucumber. Maybe it looks like hmm, maybe it looks like a lacrosse stick. Or it's good. It's fun to play shapes with the clouds, right? You can still do this in outer space clouds as well as ones that float through your sky.
Absolutely. You can really interpret anything how you'd like.
All right, so what we're going to do now is escape our galaxy and fly even further out. So we're going to try to zoom to distances that are definitely more unfathomable than this. So we'll remove the Eagle Nebula and try to leave our own Milky Way galaxy.
And also, just in case it can help anybody else who was trying to find that eagle, somebody pointed out that if you tilt your head to the left and you look, there's a bright red star that is the eagle's eye. So just one more thing to look out for. But
I
yeah,
see it.
let's go ahead and take this down and go ahead and see some more beautiful images that Hubble's done for us.
Yeah, so the myriad of stars around us, the things within our own galaxy, uh, what used to be thought of as pretty much the only things in the entire universe. That the astronomer Edwin Hubble was actually the first one to really point out and solve a uh, very old problem: is our galaxy everything in the universe? He managed to show that there's much more out there than just our own galaxy. But things that confused him were things like planetary nebulae. And part of the solution to the answer was the globular clusters. So far out of our galaxy and around the center. So we're actually going to pan out, I think, a little bit more so we can see the center in just a moment. But we have these beautiful globular clusters. They have a silly name because they're like globs of stars, like beehives of stars. They're very old stars in comparison to the open clusters that are blue. These globular clusters are more yellow, orange, and red colors because those are the stars that live for very long times. These stars are, some of them predate the age of our own galaxy, that they formed before the galaxy really took shape. So these stars could be 13 billion years old, and possibly some could live to be trillions of years old, theoretically.
That's pretty impressive. I wish I could live to be 1 trillion years old.
You'd get to see some of those stars die.
Yeah.
Imagine the planetary nebulae they would form. I don't think Hubble will last quite that long, though, to take pictures of them. We can cross our fingers and hope. But the globular clusters revealed where the center of the Milky Way was. And I'm getting a little ahead of myself here. There's one thing I want to slow down for and take a look at, which is the Cat's Eye Nebula, because we have a great 3D rendering of this thanks to Hubble. The Cat's Eye Nebula you might recognize from your set of marbles that you keep in your cabinet. That shape of the Cat's Eye Nebula will be recognizable once we fly up to it. Here we go. We're going to pan around. This is also a planetary nebulae. Beautiful. And you can see the burning white core of the star at the center. This is a core of carbon that is slowly degenerating over time. Now, if we fly through this nebula a little bit, you'll get to see the different wisps and strands and how these planetary nebulae actually have three-dimensional shapes. They're not just rings like we usually see them as, or they're not just like butterfly shapes. They have a structure, and we can't usually see the structure that is closer to us. We can see the structure that is sort of perpendicular to our line of sight. Amanda, can you show us a picture of what Hubble actually took? What is the Hubble picture of this?
Absolutely. Let's take a look.
There we go. Looks just like our model.
We almost lined it up perfectly, too.
That's right. How wide is a typical nebula like this? The Cat's Eye Nebula. What a great question. I would say that something like this is maybe a few light years across. If you give it enough time, these things can expand to very vast sizes. Now, the star themselves, before it died, was probably about the size of about out to the orbit of Earth. So it'd be something like a few 100,000 kilometers, I think a few 100,000 kilometers. 100 million kilometers, I should say. Yeah, 100 million kilometers across. But then when it actually starts to die and puff out its outer layers, I'd say it probably reaches something like a few light years in size. Great question. All right, let's keep zooming out now, because like I said, the globular clusters were a key to this story. The globular clusters revealed where the center of the Milky Way was. Because if we knew that we weren't in the center, and the center of the Milky Way was somewhere else, then we have very little reason to believe that the galaxy is everything there is. That there might as well just be copies of this galaxy out there. That if we're not at the most special place in our galaxy, then there could be numerous other galaxies that make us feel even more ignored. All right, yeah, correction in the chat is about a fifth of a light year across would be the size of something like the Cat's Eye, or the core of the nebula. All right, so as we leave the Milky Way, we're now going to show you other nearby galaxies. We're finally seeing the core of our galaxy a little bit more clearly up at the top right-hand corner there. Our whole galaxy has something like 200 billion stars in it. And Hubble, when it's trying to look through our galaxy, has difficulty looking straight along the plane. It's easier to look up and down out of it because our galaxy is flat like a pancake. And especially if it tries to look toward the center, it's very difficult to see things on the other side. So needless to say, this image of our galaxy is definitely not a real image. This is just sort of an artist's conception based off the best up-to-date data we have. And the same applies for these nearby galaxies. We can't see them from the other side. We can only see them from the one angle, from the point of view of Earth. We can't see them from all directions, so we have these little two-dimensional pictures that we're showing for you here. The ones that popped up like eyes to the side of the Milky Way are the large and small clouds of Magellan, because Magellan famously started documenting them when he did his worldwide tour. We're going to fly so far away that we can see the Andromeda Galaxy. There it is off in the distance. Highlight it there. The Andromeda Galaxy was Edwin Hubble's, I suppose, greatest success. That by observing the Andromeda Galaxy, he managed to prove that it was beyond our own galaxy. It wasn't a nebula inside of our galaxy. He proved that it was his own galaxy in its own right. And now we know the Andromeda Galaxy is something like a few times larger than the Milky Way. It might have something like 1 trillion stars in it, when our own Milky Way only has about 100 billion or 200 billion stars. And we're going to show you this great picture of the Andromeda Galaxy, one that actually does it justice more than our 3D model here does. There we go. And if we zoom and enhance, we're going to zoom in closer and closer. Hubble is actually taking such great views of these different pictures that you might not believe it, but if you look it up on the Hubble site, go to hubblesite.org, you can find amazingly high resolution images of these things like Andromeda, the Carina Nebula. If you're interested in, say, a 4K TV or an 8K TV, Hubble has managed to take mosaics of these pictures that go up to 30K or more. So Hubble is done some spectacular work, better than we can show you here on this YouTube stream. All right, now we're going to put a box around this part of our galaxy because this part of our universe, because this part of our universe are pretty much all the galaxies around us that are connected through gravity. That we know someday in the future, the Andromeda and Milky Way galaxies will collide and combine to form Milkdromeda, or the Andromeda Way, some super galaxy. I don't know, what would you call it, Amanda?
I honestly am super impressed with Milkdromeda. I kind of like that one. I think that's the way. I think that's the move.
Well, the other small green dots there are all just like dwarf galaxies around it, and these ones are all connected via gravity. But there are galaxies way beyond this that are so far away that they're actually going to drift away from us before they could ever collide or merge into bigger galaxies with us. That these galaxies have their own fate. And Edwin Hubble proved that the universe is expanding. We're going to enlarge the size of these points because every point you see here is just a galaxy, an entire galaxy with 100 billion stars or so. And we're going to try to make the pictures on all of them a little bit bigger and brighter. Thanks to Hubble, too, for taking some of these glorious pictures. And so all the galaxies that were lied beyond that cube are expanding away from each other. And throughout all of human history, they're eventually, even beyond human history, they're eventually going to expand for all the history of the universe. They're going to expand so far away that they will go out of sight and we'll lose them for good. Let's take a look at some of these pictures first before we continue with the story, because Hubble's done a great deal of work on these pictures. I think my favorite ones are pictures of galaxies that Hubble has done. Here we go. A lot of the ones that we're bringing up here are spiral galaxies. Some of them you're seeing edge on, like the Sombrero Galaxy. Some of them are spirals. And the one in the middle, let's actually let's just show that one taking up the whole screen. This is the Hubble Ultra Deep Field. This is probably the most famous Hubble picture, is of all these galaxies. This is 1/26 millionth of the sky. And the story goes that the person who sort of was the lead driver of getting a Hubble Space Telescope into space, they were granted something like a week's worth of time to do whatever they wanted with Hubble because they had spent so long trying to get it to work and getting it in space, being the mission director, that they had about a week's worth of time to use Hubble to do whatever they wanted with. And so they pointed Hubble at the darkest patch of sky they could find, one where there didn't seem to be very much at all. And they spent all of their time exposing Hubble into this one patch of sky. And this is what they saw. They saw a universe replete with galaxies. Every dot you're seeing in there is a galaxy, besides, I think, 4 or 5 stars. And even the most faint little blurry specks you can see in there are distant galaxies, almost half of the way to the edge of the universe. And some of them, you could even say, are so far away that some of them are contenders for the furthest galaxies ever seen. Hubble is uniquely situated in space to pick up this great view of our universe. And if we were to use it to look at all patches of the sky, then it would be, we would know just how filled to the brim the universe is with galaxies. I'm not actually sure where this picture was taken. I think it was taken in Fornax constellation. Now,
That picture is definitely very beautiful. It's hard not to be moved when you look at it, especially once you know the story behind it.
Absolutely. There's so many galaxies in this picture that when you think about our place in the universe, it seems so much insignificant. Let's see if I can fix my webcam again. Now, what we're going to do is we're going to go back to our normal galactic view and remind ourselves that Edwin Hubble was trying to determine our place in the universe, partly that the universe is not just our own Milky Way galaxy, but that the universe itself is expanding. Oh, great. It is in the Big Dipper. Awesome. And the expanding universe was something that was very contested when it was first thought of. That Albert Einstein famously said that he thought the universe was constant and eternal. In all the math and all the equations he was trying to do, he was trying to prove that the universe was always the same state. But Hubble, with his telescope and his assistant Adams there, managed to prove that the actual universe itself is expanding. It's not constant, it's not eternal the way that Einstein would have wanted. So it's very difficult to prove somebody as smarty pants as Einstein wrong, but Hubble did it. And you can see him there with his pipe, musing over what is Einstein looking at through my telescope. So this graph here shows Hubble's plot of the distance to galaxies and how fast they are moving away from us. And he saw a connection, a relationship between the further away they are, the faster they seem to be moving away from us. And nowadays we know this is Hubble's law, that distant galaxies, if they're twice as far away, move twice as fast. And if they're 3 times as far away, they move 3 times as fast away from us. So now we know the whole universe is expanding. And we could use the Hubble Space Telescope to try to measure then, based off that fact, what if we were to rewind back the clock from the expanding universe and we were to let it recombine as we went back in time? We now can determine a source, an age for the universe, and that age is 13.8 billion years. 13,800,000,000 years old. So our universe, its age, our place in time and in space has been dramatically changed and altered by Edwin Hubble and the Hubble Space Telescope. And I'd like to especially point out that it was 100 years ago, I think last month marked 100 years ago, that there was a great debate, the famous great debate between 2 scientists trying to prove whether or not the Milky Way galaxy was everything in the universe or if there was more than just that. So it's been 30 years of Hubble, and 70 years before it launched was when this great debate had happened. And so now, 100 years later, we can look back and appreciate the age of our universe, where we live inside of it, and the value of space exploration and putting these space telescopes into outer space. So let's go back to Earth now and say happy birthday to Hubble one last time. And this is a great time to tell us your questions.
if you're not too distracted by the beautiful flight home.
I'm going to correct our moderator. The Hubble Ultra Deep Field is in the constellation of Fornax, the Furnace. All right. Yeah, I do want to be careful and clarify that the Hubble Deep Field is different than the Hubble Ultra Deep Field. And they also released a Hubble Extreme Deep Field because they are very creative with names. But the picture we showed you was of the Hubble Ultra Deep Field. Is the Cat's Eye Nebula actually red? How many galaxies can we observe? Do you detect speed in space? Is it the Doppler? How do you detect speed in space? Those are great questions. So as we fly back into the Milky Way, one of our home galaxy, I'll mention that we can, in our entire universe, we assume that there's something like 2 trillion galaxies, maybe 20 trillion galaxies, which that number has been refined in the last few years. We used to say that there were about 200 billion stars in our galaxy and 200 billion galaxies in the whole universe. So you only need to remember that one number. Awesome. And so that's the number is about 20 trillion galaxies. So the number has been updated over the last few years to now say that there might be 100 times more galaxies in the universe than we thought before. Is the Cat's Eye Nebula actually red? That's a great question. I don't really know the answer to that, so I'll come back to that in just a second. But how do you detect speed in space? Is it a Doppler? Yes, that's exactly what Hubble was doing. He was trying to, the astronomer Edwin Hubble was trying to actually use Doppler shift that you could measure. Actually, he was using Cepheid variables. That's right. He was trying to measure distant stars and look at their brightness. And by looking at the brightness of those stars, he knew how bright they should be as a relation to how much they pulsated. And so as they pulsated over time, they could then get a metric of how large they were versus how bright they were. And they could then tell the distance to those galaxies. And then they could use the Doppler shift to try to tell the speed at which those galaxies are moving away from us. So distance is one thing and speed is another one. So as the galaxy is moving away from us, the wavelength of light gets stretched out ever so slightly. And if it's 10 times further away, then the wavelength is stretched out 10 times as much. There are a few factors in here that make it a little bit messier than that, but that's the gist of it. All right, let's see, other questions. Is the Cat's Eye Nebula actually red? Yeah, the red is typically in space pictures is, or pinkish color is what we call H alpha, which is when you take hydrogen gas and you make it really hot, it emits like reddish pinkish light. And so generally astronomers will color code the pictures so that pinkish reddish light is corresponding to hydrogen. Hydrogen is the most ubiquitous gas in the entire universe. So when you see a star that's died, its outer layers being sloughed off, this red color is, I would say it's oversaturated. It's probably just enhanced for this picture and for many pictures, but the pink typically is the hydrogen. The reddish and pinkish colors are typically hydrogen gas. That's really, really hot. Great question there. Let's see. So the Cat's Eye Nebula, I should also add in though, has like this greenish parts to it and the blue core at the center. So there's a little bit more to it than just that. Can you see the Hubble telescope from Earth at night with the naked eye? You know, I have to believe that you probably could. I'm not sure, but I would say that's probably just like a satellite in low Earth orbit, and it's large enough that it probably has enough light reflected back to Earth. that you could spot it with your naked eye. Now, something like the International Space Station is so large, right? It's like the size of a football field that when you see it up in the sky, it's actually like a super bright dot. And there are other things that are just the size of like normal satellites, maybe something smaller than Hubble, that when they orbit around and tumble around, their solar panels can reflect an enormous amount of light back to Earth. Hubble is not really tumbling, um, so they probably try to keep it at a pretty moderate temperature, and um, yeah, I would say you may be able to see it. Um, yeah, I've never seen it myself. At least if I have, I wouldn't know it. But there are something like 5,000 satellites in orbit around the Earth that are functional, 10,000 things orbiting around the Earth, whether they're functional or not, satellite shaped. And you can pick out a lot of those, especially now that we have the Starlink satellites up there from Elon Musk and SpaceX. They reflect a lot of light. Will they let Hubble crash, or will they control its fall? This is a huge question. What's going to happen to Hubble once it reaches the end of its life? So Hubble underwent a number of servicing missions, and it was supposed to have 6, but they limited it to only 5 so they could decommission the space shuttle sooner. Of course, the space shuttle had some very tragic accidents, so we may have prevented further disaster, but it may exacerbate problems with Hubble in the future. So we believe that Hubble is going to fall out of the sky around 2028 to 2040. So somewhere in the 2030s is the most likely time for Hubble to finally be slowed down by the atmosphere and be dragged back into the Earth's atmosphere and burn up on reentry, if nothing is done to it at all. The Hubble Space Telescope is, since it's only a few hundred miles above the Earth, there is like this little bit of atmosphere around there that is zipping through, and that's what's causing it to very slowly degrade in this orbit, so it might eventually re-enter. Now, the question is, can we develop a space program to get up into space and save it, or will somebody volunteer to try to save it? Can we just take Hubble and boost it so that way its orbit is higher? Even if all the components fail, it would be a great museum piece. Letting it just fall back to Earth is perhaps disgraceful or distasteful. Then again, if we were to control its landing, that might be very beautiful too. Let's see, other questions. Yeah, will they control its fall? So I would say that Hubble is probably going to stop working within the next few years, at least within the next decade, if nothing is done, because its components are very slowly failing. What we don't really appreciate is that every time they went up there, they fixed things, like whether they were gyroscopic wheels, they were solar panels, they did correction to the optics, of course, the recorders inside. They did a lot of repairs to Hubble. And they've discovered that particulates, specifically from rockets that were launched into space, even the particulates from the fuel are going so fast that when they hit it, they're going about 6 miles every second. That's about 20,000 miles an hour. So these things will hit Hubble's solar panels so hard that they can actually leave dents and they can mark it up. So it's slowly being battered, and the odds of it being hit by something that would actually end its life going right, if it's going tens of thousands of miles an hour, even a something like a centimeter wide, has about a 0.3% chance of hitting Hubble every year. And that chance has doubled since it was launched. So that means if it were just to go on indefinitely, the probability of something impacting it increases each year unless we do something to stop it. One question that was submitted online was, how far away is the farthest galaxy that we know of? This is a great question, and it's about 3.2 was the previous contender, but astronomers keep going further. So now the furthest contender is 3.3 billion light years away. So that's only about half a billion light years after the universe formed. So if we were to measure um, space like a timeline, that the light from that galaxy left the galaxy about the galaxy about 13.3 billion years ago and has traveled all the way across the universe to eventually reach our telescopes. And that means that it almost is as old as the age of the universe itself. It took some time for the galaxy to form, about half a billion years, but this is the oldest name in galaxies. It's called GNZ11. Now, if you come back on May 22nd, we're going to be talking more about galaxies. So I encourage people to check out our stream then. Okay. So it looks like our questions have ground to a halt. Much better than how we ground Hubble's mirror down. But I'd like to just pitch out that if you come in next week on Monday, Wednesday, and Friday, we're doing our solar system tour. So come back Monday at 11 for K through 5, kindergarten through 5th grade. Wednesday at 11 a.m. for 6th through 12th grade, and see us again this time next week for 4 p.m. to see the solar system tour. Now, I want to also say that the best way you can help us is to like and comment on this video. The more buzz you create and you share it with your friends, the better it helps our channel to grow and eventually share our love of astronomy with others. But I want to give a big shout out to Amanda.
Yeah, thanks. It was a lot of fun. And happy birthday, Hubble.
That's right. Happy birthday, Hubble. Do we need to sing now?
Oh, I think we're okay.
Happy birthday to you. Happy birthday to you. Happy
Happy
birthday,
birthday,
dear
dear
Hubble.
Hubble.
Happy birthday to you. And many more, certainly. Once again, like, comment, and subscribe on this video. Thank you, everybody in the chat, and we'll see you next week. Thanks again to our chat moderators, Jeremy and Brianna, and have a good rest of your day. Goodbye.